This video is on using solubility rules to identify insoluble compounds. Because water is polar, it can dissolve many other ionic compounds since they both have some sort of charge. But water cannot dissolve all ionic compounds. Sometimes the attraction between the ions is just too strong. And when that happens, the water can't get in between the ions, and so the ion does not dissolve, and those they stay stuck together in that crystal lattice structure. So how do we know if something will dissolve, if an ionic compound will dissolve in water or not? Well, we have solubility rules for that. Now, these solubility rules are located in your reference tables. So this is something to be used and not memorized, at least at this stage. It seems very straightforward in how we would go about reading these solubility rules. You have an insoluble category and a soluble category. But because there are exceptions in here, it makes things a little more difficult. But all in all, it is just reading the solubility rules, and I'm going to show you how to do that. So what we're going to do in reading our solubility rules is we're going to look things up by the anion. So that's what we're going to look at first, and I call those the last things. Let me show you here. So if I have, let's say, so if I have MgCl2, the anion here, or the last thing, would be a chloride. And that's what we would look up first. So they're all categorized by their anions. So you look the last thing up and find it. And in this case, it is going to be right here. This is a chloride. If it ends in IDE, that means it's an element. So this is a chloride. And I use the headings in this when I read it. So all chlorides are soluble except, and when we get to the except part, that's when we're going to take the first things into account. So all chlorides are soluble except if it's bonded to silver, lead, and mercury, then it would be insoluble. Well, this is magnesium, so this is soluble. It isn't one of those exceptions. So this would split up into its ions in water. Now, going through and looking at these last things, I want to show you those a little more, and then we'll practice with this just a little bit. All right. So the first, under the soluble category, I like to go through and underline the different types here. So nitrates, that would be your NO3s. So if it ends in NO3. Acetates, so if it ends in this C2H3O2. Or if it starts with ammonium, NH4. That means they are always soluble. Also, anything that is bonded to something in group 1, and here are the most common ones that you'll run into. Any of these, if it's a first thing, these will never produce precipitates. They're always going to be soluble no matter what. There are no exceptions here. So all of these are soluble. The next one was one that we just looked at, having to deal with the chlorides, the bromides, and the iodides. So this is most of the halogen family. So if it ends in Cl, Br, or I, these guys are soluble except if they're bonded to silver, lead, and mercury. So unless they're going to be soluble, unless they're bonded to one of these. And if they're bonded to one of these, then they're going to be insoluble. Fluorides are soluble, except if it's bonded to something in group 2, lead 2, or iron 3. Sulfates are SO4. We want to write that on your solubility rules so that we don't confuse it with a sulfide over here. Sulfates are soluble unless they're bonded to calcium, strontium, barium, mercury, lead 2, or silver. So again, we see that mercury, lead, and silver. They tend to form insoluble compounds. Now, over here on the insoluble category, we have all carbonates and phosphates are insoluble. So CO3s or PO4s, if it ends in those, they're going to be insoluble unless they're bonded to something that's in group 1 or ammonium. All hydroxides are going to be insoluble unless it's bonded to group 1, strontium, barium, or ammonium, and hydroxides, that OH there at the end. All sulfides, now if it ends in IDE, that means it's an element, so you may want to write this on your solubility rules. So all sulfides tend to be insoluble, except for group 1, 2, and ammonium. And oxides, anything that ends with oxygen tends to be insoluble, of course, except if it's bonded to group 1 or ammonium. Now, let's look at another couple of examples. And let's see, here we go. All right, so if I have CAF, I'm going to look that up by the last thing, which my anion here is a fluoride. And I find fluorides, right here. So it's in the soluble category. All fluorides are soluble, except if it's bonded to something in group 2. And you know what? Calcium is a group 2 element. So this is insoluble. Let's look at another example. CAS. Well, we're going to look it up by the anion, or the last thing. This is an S, so this is a sulfide. All sulfides are insoluble, except if it's bonded to something in group 1, 2, or ammonium. Well, we just established that calcium is a group 2 element, so that means this guy is going to be soluble. So that's just a little quick look at how to read these particular solubility rules and how to use them, and looking at some of those exceptions there. Okay, so I have, you're going to use your solubility rules, and I want you to, out of these that I have right here, decide which ones are insoluble. So you can pause this video and then we will go over it. Okay, so let's see. I'm going to make this larger, and there we go. So I can have my solubility rules there. All right, so if we look at the first one, silver chloride, it is a chloride, and all chlorides are soluble except if it's bonded to silver. So AgCl is insoluble. So that should have been one that you wrote down. The next one, NaNO3, that's a nitrate. And all nitrates are soluble. There are no exceptions. Plus, it's bonded to something in group 1. So that is all kinds of soluble. This one would be not one that you wrote down. The next one, KCl, all chlorides are soluble, and potassium's not one of these. You could have looked at it that way, or this is also something bonded to group 1, and those are always soluble. FeS is a sulfide. All sulfides are insoluble, and iron isn't any of those exceptions, so this FeS would be the next one that is insoluble. Al2SO4 is a sulfate. All sulfates are soluble except, and aluminum's not one of those exceptions, so aluminum sulfate is soluble. PbCl2, all chlorides are soluble except lead, so that one's insoluble. The next one, BaSO4, all sulfates are soluble except barium, so that one's also insoluble. The last one is a hydroxide. All hydroxides are insoluble except for ammonium, so this one is all kinds of soluble. These should have been the only 4 that you wrote down.